Unit 18, Part 8. Okay, so now let's universally instantiate from 1, okay? We've got FA and not GA, which we could obviously put together, okay? Now, I'm going to universally instantiate from 1, step 9, right? Universal instantiation, so when I do UI on 1, I am determined with regard to what variable I'm deleting, right, or getting rid of, namely the x, of course, because it's a universal statement and it's the universal x quantifier, which is the leftmost quantifier. So if that's the quantifier I've got to be dropping, it is not legal to drop any other quantifier except for the leftmost one. But with what, right? What do I universally instantiate to? What is the individual that I instantiate to? A or B or C? Well, if I instantiate to A, and now I'm matching these guys, right? I get FA and not GA as, I get a conditional with that as its antecedent. If I instantiate to A, right? This is the matching, so I'm stressing the matching you're doing, which determines your choice of what instance to universally instantiate to, which is something you have to pay a lot of attention to because it's a big element, a major element of getting these proofs right? So where am I looking? What am I thinking? I'm thinking that I've got these two, I can conjoin them, and if I universally instantiate to A in particular, what I'll get is a conditional with the conjunction of these two as its antecedent, which will make available a modus ponens. So let's do that. So it's FA and not GA. Now, hook, oof, in the throat. Notice also what happens, just right over here, UI, A for X, Y. What also is going to happen is I've done that matching, FA and GA, but that also, right, now I'm having done that and had made that decision, it's determined what these X's are, of course, because in instantiating, every X gets replaced with the same individual constant, right, to do a proper instantiation. So what this comes out is, right, the Y's, all the other variables stay in place, as well as the other quantifiers, so that's that. And what does this become? T, Y, A, and H, A, Y. Again, must be very attentive, very careful when you make such moves, instantiations like this, right? It's the second place of the T, yet the first place of the H that gets replaced with the A, right? So first place of the T and second place of the H remains a Y, Okay, but let me notice this. This is something you should notice. I've got the T here, TYA, one of the two variables has been resolved into an individual constant, as it were. And look at this, right? And also the way Klenk thinks it out, she's clear that, right, thinking this backwards another step, it's not TA and not ZA, not TBA, right? And not that. So how are we going to get that? What's its form? It's a conjunction. What rule gives us conjunctions? The rule of conj. So you want to get these two individually. So you want to get not TBA. That's something I want to derive. That's half of the whole that I need to get home. And it's probably going to come from here. This is the only T amongst the premises. That the T in premise 1 is the only T. So far, so good, right? The second position, right? Why is it an A here? Because of the matching I did with these guys. I wanted these guys to be A, right? So that these could combine, right? modus ponens to this, right? H, A, Y, right? So this is A because I matched the FA and not GA. I wanted it to be FA and not GA. I wanted the X's here to become A so that I could use these two formulas to do a modus ponens. Yes? But in doing that, in making that choice, the second position of my T became an A, right? Mechanically now, following the rules of universal instantiation, you've got to replace all the A's. All the X's, you've got to replace all the X's with an A, with the same individual constant. And now I check to see where I'm going, and I think to myself, oh, so far, so good, right? The second position of the T is an A, right? And in the T that I need here, the second position is an A. Good, I'm on the right track. I probably have done the right thing. If not, maybe if it's not the case that whatever letter this is here matches this letter here, if they don't match, if you've got an A there and a B there, or a D there and an F there, you won't have that. You shouldn't really need to use A or B. But if they don't match, if one's an A and the other one's a B, you might want to rethink or check. It's not necessarily wrong. This, you know, in speaking more generally, right, just outside the context of just these specific premises, in general, it might not be the case that this T is the T that gets you there. There might be other instances of the relational predicate T. All right, pressing on. So you see, if a modus ponens to this, okay, well, that is not in quantified form, so I want to transform that as well, right? Okay, it's the same transformation as before. This is not I, right? This is not I. It's still a not I. This is still an I form. It's still a categorical, even though the two predicates are two place. Whereas here, the two predicates are just one place. That's your familiar I from the unit 10 to 16 stuff. For monadic predicate logic, this is a relational predicate logic one, but still, not I goes to E. Oh, not H-A-Y, right? C, Q, yeah. Okay. 10, 11, 12. So, what am I looking at? Sort of forget about this for now. Don't draw a line in your thing because I've got to grade it on the exam, but I've got this information, and I've also got the information in 3, right? So these are the ones I'm looking at in terms of I'm going to be doing stuff from them as I go forward. And I'm looking, again, still to match them. So now let me universally instantiate from 3, okay? Here, I'm going to be deleting the X, replacing the X with some individual constant. Which one, right? Well, it's going to change this one, the first place in the H, and the first place in the Z, as well as the X here, right? So what do you want? It looks like you want, there's sort of 3 elements of matching, or there's 3 points, 3 data points, if you will, for matching, which will tell you what you should replace the X with in the universal instantiation. The easiest one, I think the one that Klenk refers to as she works through it, is, right, this is where it's important to think 2 steps ahead when inspecting the form of your inspecting the form of your premise and thinking, and not only answering the question, what is its form, but also, if it's in quantified form, what will the form be after instantiating, right? Because here, the form will be, as we said, a conditional, right, with this as the antecedent. That whole thing is the antecedent, and that is the consequent, which means what? What you should notice is, if that is A, right, so it's the first data point, if this X is A, ooh, yum, I have the negation of that consequent, right? That's one data point, but there's more, right? This would be, if I did that, if it was H-A-Y, good, because this is H-A-Y, so matching. So I'll be able to do some kind of modus ponens, modus tollens, whatever it turns out to be, when it's A in the first position, both of this formula, right, connected with this guy, and for this formula. Whereas if I was replacing the X with a B, right, this H-A-Y would never be able to be the same formula as this one, because this is H-B something and this is H-A something. So it's good to have A. We've also seen a good reason to have this X and A, and this Z, X, Y. What should this X be? It should be A2, right? Because of the conclusion I'm aiming for is Z, A, B. That is the first of the two positions of the relational predicate Z is an A. So it's 1, 2, 3 data points, 3 things pointing you to replacing the X with an A. Yeah, I'll go down a bit. All right, so let me do that. And what do I get? So I'm doing U, I, A for X on 3, and I get for all Y, H, A, Y. Okay, be very careful here with the brackets, right? H, A, Y, hook, Z, A, Y. That is the antecedent, right? And it's hook, G, A. Okay? You've got to make sure in this instantiating as so that you get the form right? Notice especially that, and you might be in the habit of doing this, so you think this is the right thing to do. Notice that it is not the case that this is a universal. It's not the case that there's a brackets, right, here and here. It is not. This is not a quantifier. The result, the proper instantiation, does not result in a universal statement. So, as I gestured at before, this is what she warns you against, the mistake she warns you against on 348, second last full paragraph. One final reminder, these words here, again. One final reminder about the importance of parentheses. You must be very careful in dropping your quantifiers to be sure you really do have an instance of the propositional function, okay? This is a perfect example of what she's talking about. Make sure that this instance here, this instance is an instance of this propositional function. You've only done it right if you get a conditional, right? If you don't, and get your parentheses mixed up, you may scuttle your proof. If you had the following inference, for example, you would use UI as shown, and this is very close to the one we just did.